In this video, we'll write the balanced net ionic equation for PbNO3 2 plus NH4 2s. This is lead 2 nitrate plus ammonium sulfide. The first thing we need to do with net ionic equations, we need to balance the molecular equation. This is our molecular equation. So let's see, we have 2 ammonium ions here and only 1 here. Let's put a 2 in front of the ammonium nitrate. 2 ammonium ions, but now we have 2 nitrates. That's fine because we have 2 nitrates here, and we have a lead on each side and a sulfur. So we're done. That's the balanced molecular equation. Now we can write the state for each substance. Nitrates are very soluble, so we're going to write AQ for aqueous. It'll dissolve, dissociate into its ions. Ammonium compounds also very soluble, so aqueous. But for sulfides in general, they're insoluble. And lead sulfide, this is an insoluble compound. That means when these two substances react, they form this as a solid. And because it's a solid, it falls to the bottom of the test tube as a precipitate. So we have a precipitation reaction here. Then we have ammonium and nitrate. This will be soluble. We write AQ. Once we have the states, we can split the strong electrolytes into their ions. So for lead 2 nitrate, we don't know the charge on lead because it's a transition metal, but we do know the whole nitrate. That's 1 minus. We have 2 of them. This has to be 2 plus. So we have the lead 2 ion, and I won't write the states now. Let's write those later. And then 2 nitrate ions. So 2 of these NO3 minus, the nitrate ion. The ammonium ion, the whole thing, is 1 plus. Good one to remember. The sulfide ion, 2 minus. We have 2 of these ammonium ions, so 2 NH4 plus, and then just the 1 sulfide ion, that S2 minus. These are the reactants in our net ionic equation. For products, we don't split solids apart in net ionic equations, so PbS, that stays together. This is lead 2 sulfide, plus we have the ammonium and the nitrate, so 2 ammonium ions, and then we have 2 nitrate ions. And these are the reactants in our net ionic equation. At this point, we can cross out the spectator ions. They're on both sides of the complete ionic equation. So here we have our reactants, and down here are our products. In the reactants, I can see there are 2 nitrate ions here and 2 nitrate ions here. So these are spectator ions. We'll cross those out. And in the reactants, we have 2 ammonium ions, and in the products. So these are spectator ions, and we can cross them out. But what's left, that's the net ionic equation for lead 2 nitrate plus ammonium sulfide. I'll clean this up, write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for PbNO3 2 plus NH4 2s. You'll note charge is conserved, 2 plus, 2 minus. That gives us a net charge of 0. Products, this is neutral, net charge of 0. So charge is balanced, and if you count the atoms up, they're balanced as well. This is Dr. B with the balanced net ionic equation for lead 2 nitrate plus ammonium sulfide. Thanks for watching.